Hi guys, so this is the lesson that starts our chapter 4, which is all about the reciprocal function. So this is lesson 4.1. It's called the inverse variation and the reciprocal function. Today, this lesson is just going to work on inverse variation. So what comes to mind when you hear the word inverse? Okay, inverse should sound like something like opposite, the flip of something. If we were in class, I'd probably have you guys all brainstorm what comes to mind when we hear the word inverse. So let's take a look at this table. Do we think this represents an inverse variation? Some things to notice. Let's take a look at these x values. 1, 2, 3, 4. They are all increasing. And let's take a look at the y's. 12, 6, 4, 3. They're all decreasing. Increasing and decreasing, they're opposites. That's part of the definition of inverse variation. Let's see. The inverse variation is a relation between two variables such that as one increases, the other decreases. But there's another part to this, proportionally. So they're not just going up and down or increasing and decreasing. There's more. They need to be proportional. What this means is they need to be increasing and decreasing at the same rate. So how do you figure out whether they are proportional? What you need to do is you need to find the product of x and y, and it needs to be constant. If the product of all the x and y's are constant, then I know it's an inverse variation. So let's take a look here. I'm going to make a new row here. X, y, the product, right? Multiplication. 1 times 12, 12. 2 times 6, 12. 3 times 4, 12. 4 times 3, 12. Guess what? 6 times 2, 12. 12 times 1, 12. Notice the product of x and y is constant, right? So I can say, yes, this table represents an inverse variation. And that's all it is, guys. Really simple. Let's see. I'm not sure if I have another one. So just be careful. You have to check all of the pairs. So notice like I checked all of them. 12, 12, 12, 12, because maybe the last one isn't going to be 12, right? So you want to make sure you check all the pairs. Okay, we'll do another one. So does this table of values represent an inverse variation? So x's, they're increasing, y's, they're decreasing. So far, so good. But there's a little further step that we need to find the product, and it needs to be constant for me to say, yes, it's an inverse variation. 1 times 20 is 20. 2 times 17, 34. 3 times 14, 42. It's not good, right? They're not constant. These values, the product of x and y, are not the same. So we will say, not an inverse variation. Oh, it's just not worth typing. Okay, awesome. Let's look at another. So you're going to do these try-its in the practice section after you watch this video. So what is that product called? So we're not just going to keep calling it the product of x and y. It's actually called the constant of variation. Okay, so we can go through and find x and y, x times y, 1 times 24, 24, 2 times 12, 24, 3 times 8, 24. It's going to be 24. My constant of variation is 24. And we use the variable, because x times y, it's not a lot, but it's kind of a lot to write. We use the variable k to represent the constant of variation. So in this case, k equals 24. Okay, that's our constant of variation. There's another version of this equation. So this becomes a formula. xy equals k. Let's say we want to solve this for y, right? If I want to solve this for y, what would I do? I would divide both sides by x, right? So then we would say y equals k over x. And this is the formula that represents inverse variations. So if we want to write an equation of this table, we're going to use this little formula. Okay, notice it can also be x equals k over y. It does, like the x and the y can flip. But it all stems from the fact that k, the constant of variation, comes from multiplying x times y. okay? Where this comes into play is doing this example. So let's go through. When we go through, we're going to make a list of things I know and things I need. So it says, in an inverse variation, x equals 10 when y equals 3. I know that, right? So I can put that in my know list. Write an equation to represent the inverse variation. So that's the first part. And then find the value of y when x equals -6. So when y, I don't know what y is, but when x is -6, find y. That's what I need. And it kind of goes together. This x and the y go together, and this x and the y go together. So the first thing we have to do is write an equation. The equation, remember the formula, comes from y equals k over x. As soon as we see inverse variation, this is the formula we use. How do we find? The most important part of this formula is k, right? I need to find k first by doing x times y, and I find k by using what I know in my know list, right? K equals x times y. So k equals 10 times 3. 10 times 3 is 30. My equation is y equals 30 over x. And that's it, guys. That's the first part of the question. Write the equation that represents the inverse variation. Easiest equation we've ever written, right? Next, find the value of y when x equals -6. Any ideas how we're going to do that? So, in order to find the value of y when x equals -6, we just plug it right in, right? So we're going to now say y equals 30 over -6. 30 divided by -6, what's that going to be? -5. And that's the second part of the question. What is, find the value of y when x equals -6. There it is. Okay, awesome job, guys. This is all the lesson for today. You're going to go to the practice section and do a practice version of this example. Great job, guys.